Good day to everybody. Let's continue with our discussion on set theory. And for today, we will be discussing a way in representing our sets. So in the last lecture, we have mentioned that we can actually uh, denote a set using capital letters, and then elements of the set will be enclosed by curly braces. So if we just use the roster method or the listing down method, we can just uh, separate each element in our set by uh, commas. So this is the listing method or the roster method. And then we have also mentioned that we can also rename the set using our rule method. So in the rule method, we say that a representation, let's say x, such that we now describe. So in this case, we have x is a vowel. Okay, so that's the rule method, and we have the listing down method. So for today, we will be reviewing what we call our Venn diagram. So I'm sure this is not new to you. We will just be reviewing our Venn diagram. So just a quick review. For a Venn diagram, we always have the universal set represented by a rectangle. So we have our universal set. And in our last lecture meeting, we have said that any element given in a set is always a member of a universal set. So the universal set is represented by a rectangle. And then if we have uh, sets involved in the universal set, we can represent our sets by circles. So let's say we have this as set A, and then let's say we have this as set B. So for today, we will be reviewing a few set operations. And the first one that we will be reviewing for set operations is what we call the complement, let's say, of complement of set A, which is represented by A prime, okay, which is represented by A prime. So when we describe the complement of A prime, using the rule method, we can say that this set is the set containing all x such that x is not an element of set A, and at the same time, x is an element of the universal set. So when we talk about set complement, these are the elements not in set A but can be found in the universal set. Therefore, if we will use the Venn diagram to describe this, so we have our universal set U, and let's say this is our set A. So if we will now describe where the complement is, it will now be the section outside set A, but can be found in the universal set. So the shaded area will now be the section for A prime. Okay? So any element that you find in the shaded region will now be your A prime. So you will find that in the shaded region, these are the elements not in A, but can be found in the universal set. So that's the uh, complement of A. So we also have what we call the set difference. So set difference, let's say we have two sets involved, set A and B. So if we want to get the difference between set A and set B, so let's say we would like to get set A minus set B, set difference. To describe this, this is the set containing all x such that x is an element of set A and at the same time x is not an element of B. So this will be the set in A but not in B. If we will now represent this using a Venn diagram, so we have our universal set U. We have two sets involved, set A and then set B. So if you will look at the description, these are the elements in A but not in B. Elements in A but not in B. So we do not include this part because though these elements are in A, but these elements are also in B. So if we have A minus B, so A minus B, the shaded region there is your A minus B. Elements in A, but not in B. So that is your set difference. And then we also have what we call disjoint sets. Disjoint sets. So when two sets are disjoint, it means that, let's say A and B, it means that when we get their intersection, it must be the null set. Oh, forgive me. We will define later what the intersection is. But anyway, when two sets are said to be disjoint, if you will look at it, forgive my drawing, that's your universal set. So this is your set A, this is your set B, set A, and then set B. So they don't have a common element, so they are disjoint. But before we go further, let me define the intersection. Sorry. So when two sets are intersecting, so A intersection B, intersection of sets, we now define this as the set containing all x's such that x is an element of A and and x is an element of B. And using our Venn diagram, that's our universal set. Just imagine that that's a rectangle. Forgive me, it's so difficult to write on this pad. So that's your set A, and then that's your set B. Intersection of sets. From the definition, if you will now locate your x, it is in A and at the same time it is in B. So in this diagram, the section common to A and B is your A intersection B. Section wherein you can find your element in A and at the same time you can find your element in B. So that's the intersection of set. So if we have the intersection of set, I'm sure you are also familiar with the union of sets. And in the union of sets, let's say we have A union B. If we will define this using the rule method, this will be the set containing all x such that x is an element of A or x is an element of B. So look at the definition. The only difference will be their connective. For the intersection, we use and. For the union, we use or. Therefore, if we will now look at this one through a Venn diagram, we have uh, oops, let me fix that. So we have our rectangle. Talagang ayaw dumiretso. So that's our universal set U. we have set A, we have set B. And by the definition, if we are looking at the union of the two sets, we can find X either in A or either in B. So union, we just combine set A in union with set B. So that's for the uh, union. And then let me just include the proper subset. Remember last meeting we have defined a subset. Sabi natin pag subset, we look at the possibility that the two sets are equal. But if we look at the Venn diagram of a proper subset. So if A is a proper subset of B, okay, so we remove the possibility that uh, A is equal to B. So if you will describe this, how do you describe the proper subset? A is a proper subset of B. X is an element of this will contain all. We remove that. How do you define again the subset? This will contain all X such that X is an element of A. Okay. And how do you define this? Go back to, let's just look at how we defined this last meeting, just to be sure again of how we did the definition of a subset. There you have it. So if you are looking at a subset, this is now happen. This is true for all X such that X is an element of uh, A, implies X is also an element of B. Okay, but we remove the fact that A is equal to B. Okay, but anyway, so using now our Venn diagram, so X is an element of A implies this is true for all X. X is an element of A implies X is an element of B also. Okay, so that's the uh, set notation for the subset. Now Venn diagram, for its Venn diagram, for the proper subset, where's the Venn diagram? So for the Venn diagram, A being a subset of B, okay, so that's your universal set. A is a subset of B. All the elements of A is exactly contained, or all elements of A can be found in set B. So that's your set B, and then your set A is there. Okay, so A is a subset of B. Therefore, if you will now go for the elements, diba? You get your elements in the set. Okay, A is a subset of B. It implies that X is an element of, or X, for all X, an element of A implies X is also an element of B. But we remove the possibility that A is equal to B. So we have those as our basic operations on sets. Okay, so till our next discussion, I'll be proceeding with the next section already. So I'll just keep this discussion short. Again, there are some problems, there are some exercises in your modules. Please do those exercises. Again, God bless everyone. Till our next lecture.